right, welcome back, ladies and gentlemen, to the next episode of our How to Make a 2D Sandbox series. Today we're going to get going on the lighting. So I have recorded this episode before. It didn't work out. I ended up using a different method. So I have done this before, but I've reset my progress, and now I'm going to do it all again for you guys to see. So the first step is going to our window and package manager. You want to load this up. We're going to install the URP package, the Universal Render Pipeline. That is essential for this to work. So the way we're going to set the lighting is by basically putting a giant overlay over the terrain and saying, basically hide tiles with different opacity. You'll get what I mean. It's quite a ingenious method. I'll put the link to the video in the description that I got the idea from, because it's not my original work. But so once you have package manager open, you want to say make sure this is in Unity registry, and in the search bar, if you just type in Universal, it should come up. There you go, Universal. Click it, press install. This will say install for you. It says remove because I've already done it. It'll take about a minute or two. Anyway, once we've done that, we need to actually convert our project to use Universal Render Pipeline. So we're going to go create rendering Universal Render Pipeline asset. And we're going to just call this pipeline, just like that. That's also going to, by default, give us another object, which is this pipeline.renderer. We don't need that. Delete that. You want to keep pipeline, though. That's important. You will get this message here. We're going to fix that real quick. You're going to go to create rendering 2D renderer. There we go. And we're just going to call this 2D renderer. There you go, and then click your pipeline, drag and drop your 2D renderer right here to the renderer list, and that is done. Now we're going to go edit project settings. In our graphics, we have this empty here, no render pipeline set. We just have to make sure we set that. So set your pipeline there, and that should be fine. Close that window, we're done with that. The other thing we need is this global light. So the way you get that is quite simple. Just like you would create a normal light, you go here, plus light. Now we have this cool section here, and we can just choose global light from there. Name it whatever you want, and that's all good. The last thing we need is a overlay, so for our whole terrain, obviously. So we're going to go 2D object sprites square. I'm just going to call this overlay. Set the position to be 50/50. Size should be the same as your world size, so 100 by 100 by me. I say 50/50 because that is the middle of the world. So if I was to generate a world now, it would appear right here. Now we're going to create a custom shader for this using shader graph. And the reason we need the URP is because we want to use shader graph. So the way we create a shader is quite simple. You go create, right under shaders, here we go, shader, and then it should be Universal Render Pipeline. And we're going to call this maybe Sprite Unlit Shader Graph. Choose that one. And then I'm just going to call this Overlay. Just like that. And now we're going to open up Overlay and drag that to the bottom here where we can view our shader. So if you guys have never used Shader Graph before, this is a great opportunity for you to learn. It is quite easy to use, relatively easy, I'd say. Of course, it does take a bit of practice to get used to it. But once you have hang of it, it's actually really easy to make some pretty cool stuff using it. So it's very powerful. I'm just looking at my other screen here as well at the same time, making sure I do this all right. So I think for this episode, I'm just going to do it all and then explain how it works rather than going one by one. And then if you guys have any questions, join the Discord and ask away there. So the first thing we're going to do is create a 2D texture. So texture 2D, and we're going to call this main texture. This is fundamental for our actual terrain, for our actual shader to work in a 2D setting. If we don't have this, then it won't work. You just need to make sure you set the property here in this graph inspector window. Let's open this up a bit. There we go. You can see that the reference here is called texture 2D. We need this to actually be, I believe it's underscore capital M main and then capital T text. Make sure you spell that correctly. That is important. And then we need a couple other things. So the first other thing we need is another texture 2D. This is going to be called our shadow texture. So shadow texture. This is what's going to hold pretty much our lighting. And you want to give this something similar. So we're going to call this underscore shadow with the capital S and then text. Again, make sure you spell this exactly like this. And the last thing we need is a float world size. And again, make sure you spell this correctly. We're going to call this underscore world size. Nice. And that is pretty much step 1 done. And then the other thing we need to do is make sure we set the color to the sprite to black. And now we can actually start making our shader. So to make the shader, really simple. We're going to right click, create node, position. That's going to give us this position node here with some fancy colors. You want to choose this drop down, make this absolute world. And that's going to go into a tiling and offset node into the UV. There we go, just like that. You can minimize the preview. We don't need to see that. The tiling is going to come from a divide node. Yep. There we go. And then we're going to divide 1 by our world size. Just like that. So make sure you set these values correctly. This is very important. Your shader won't work otherwise. Let's just move this out the way a little bit. The out from our tiling on offset is going to go into a texture, where is it? Sample texture into the UV slot, just like that. And then we want to set our shadow texture to be our texture here. That's going to go into a 1 minus node. So we're going to take the R channel. R, G, and B are all the same, but we're going to take the R channel for now into a 1 minus node, just like that. That's going to invert the output from here. So if you can see it goes from white to black, just like that. And that's just going to go into our alpha channel on our shader. And that, ladies and gentlemen, is your shader done. Save asset, that's very important. Minimize this, cool. And now, before we can actually view this, obviously, we need to click on our overlay, right-click it, say create, and we're going to create a new material right there. And I'm going to call this overlay as well, just like that. And now you can see we have a couple values here. Set the world size to 100 or whatever your world size is. And then drag and drop your overlay onto your overlay object. You'll see it goes transparent. That is good. That means you've done it right. And then we can start coding this. So let me zoom in a little bit here for you guys to see. Cool. Let's scroll all the way up, and I'm just going to do top to bottom, and I'm going to program the whole thing. So a couple variables we need and a couple settings we need to set. So the first variable we need is a public texture 2D. Here we go, texture 2D. And we're going to call this world tiles map, just like that. And then we're going to have a public material, and we're going to call this we'll call this light shader, maybe. Yes, let's call it light shader. And then we have a public floats light threshold. Floats light threshold. A public floats light radius. So this is how the range of your light essentially. And we're going to set this to 7. You don't want this to be too high. The higher it is, the more it lags essentially. Every time you press and break a block. And then the last thing we need is a list of positions to keep track of which blocks that are unlit at the moment. So we're going to very simply say list vector to int, call it unlit blocks, there we go, equals new list of a vector 2, just like that. And I'll give this a header here, and I'm going to call this lighting. Nice. All right. 2D lighting is going to make our terrain look so much better as well. So this is the exciting part. That is our variables done. Now in a start function, we just have to set a few things. We have to initialize all of these essentially. So what we're going to do is say world tiles map equals new texture 2D of type of size, width of world size, and then height is world size as well, of course. And now we have a couple we have a choice here to make. Do we want our tiles to be smooth shaded or not? So do you want them to look blocky, or do you want them to look a bit nicer? I prefer them to look nicer, but you know, smooth shaded, but some people may not. Anyway, to make them look more tiled, you'd simply include this line: world tiles map dot filter mode equals filter mode dot point. And basically that makes it so it looks more pixelated, and that's what gives us the illusion of it being blocky, essentially. The last thing we need to do on this section here is say light shader dot set texture. And remember that thing we set initially. So in your shader, you see that shadow texture has this option here. There we go. The reference. That's how you reference it from code. So copy that, Control C, and then paste that here. And we're going to set the value of it to, of course, world tiles map. Now we just have to make sure we set create the texture. So we have what we're going to do is set each pixel to basically white initially, just so it sort of stays that way. You'll see why that's important in a sec. So for int x equals 0, x less than world size, world size, x plus plus. For int y equals 0, y less than world size, and then y plus plus, just like that. And then quite simply, we're going to say world tiles map dot set pixel x and y to color dot white. Nice. And then we just have to send this back to the GPU by doing world tile map dot apply, just like that. Okay, so that's our sort of initialize light, basically up to here, and then under here we're going to generate terrain stuff. But in our at the end of our start method, we have to do one more thing, and that is to loop through it and basically light each tile which should be lit by applying it to the texture, kind of. Well, we're going to call the method. The method doesn't exist yet, but we're going to call it. So the way we do that is not here. After our terrain generates, we're going to say for int x equals 0, x less than world size, x plus plus again. And then again for the y, for int y equals 0, y less than world. This should be world size. And this should also be world size. There we go. Y plus plus. And then we just have to check if the pixel we're on is white by doing if world tiles map dot get pixel x and y. If that is equal to color dot white, right? Yep. And then here we're going to call a function called light block, which takes in an x, a y, one f, and a 0. So light block, what it's going to do is essentially light this block at the position of x and y at this sort of light level. That's the intensity. So intensity is between 0 and 1. So 1 is max intensity, and then 0 is the number of iterations it's on. Because this is the recursive function, basically inside the function, it's going to be calling itself as well, so that it continuously lights the blocks in a sort of growing manner, if that makes sense. And once you've done that, that is fine. Cool. That is our start method done. Obviously, that's an error. We don't have to worry about that just yet, though. The one thing we really do have to do, though, is at the end of our generate terrain method, I believe. Yes. So generate terrain at the very end, right here, we're going to say simply world tiles map dot apply. Because in here, a bunch of stuff are going to be changed, essentially. So, yes. We just need to make sure we are updating our texture in the GPU as well. And then in our remove tile function, so scroll down a little bit more, right here. Underneath, after we destroy it, we want to say world tiles map dot set pixel x and y to color dot white. Basically, what that's going to do is make it so, color dot white. There we go. That's going to set it so that our texture updates with the invisible block. And then we also have to call light block again. So in light block, x and y, again, 1f, and then at iteration 0. Just like that. Ignore these errors. We're going to fix those once we write the function for it. And then the next thing we have to do is underneath this, at the very end, we want to say world tiles map dot apply. Just like that again. So again, just updating the texture that we've changed it. Cool. Now we're going to actually start writing the light block function. So I might write this, where should I put this? Maybe at the end, at the very end. So we'll say here, void light block. It's going to take in an int x, an int y, a float intensity, and an int iteration. Cool. Now we're going to say if iteration is less than light radius, then do this. And what it's going to do, the first thing it's going to do is say world tiles map dot set pixel x and y to color dot white. Color dot white times intensity. So that's just updating the current block we're on. So it's going to set it to white. And then we're going to loop through for each of the neighboring tiles. So this is where it starts to get a bit confusing. So for int nx, so nx is neighbor x equals x minus 1, while nx is less than x plus 2, and then nx plus plus. Cool, and then we're going to do the same for the y-axis. So for int neighbor y, or ny, equals minus 1, ny less than y plus 2, ny plus plus. Nice and easy. And then we just have to make sure that the current block we're looping through is not our original block. So we're going to say if nx is not equal to x, or ny is not equal to y, in which case if this condition is met, then we just have to calculate the distance that tile is on from our original light. So our light is at this position, and that distance is float dist, and this dist is going to equal vector2 dot distance between new vector2 x and y, and then another new vector2, and this is going to be nx and ny. So the neighbor position to our original light position. That's all. Just like that. And then we're going to calculate the intensity we want this block to be. So float target intensity equals mathf dot power. So the power of 0.7. So 0.7 is sort of like a light's threshold almost. And what it is basically saying that is how much light is lost per tile that the light travels through, essentially. And then dist is the other variable inside our power function. And then we're going to multiply that by intensity. Intensity, just like that. So yeah, a little bit of math there to calculate that. And then if world tiles map dot get pixel. So now we're going to get the pixel at this position. If there is a pixel there, so the way we do that is literally say nx, ny is not equal to null, which means there's a pixel there. In which case, if there is, then we're going to say if the pixel there, so world tiles map dot get pixel at position nx, ny. If that, so we're going to say .r to get the R channel. If it is less bright than the target intensity we want it to be, then we're going to call the function again. So that's why I mean, as in recursive, we're going to call the function from within this function. So it's essentially going to keep looping. And the reason that we need this iteration is to keep track of how many iterations we've done. So like I said, light radius, it's going to loop, keep doing this function again and again until it is equal to light radius, which is why the greater your light radius is, the more it lags, because the more iterations it's doing. Cool. Anyway, the function we're gonna do is, so it takes in the position and x and y. Our target intensity is our target intensity, and then the iteration is iteration plus 1. Make sure you put plus 1, otherwise you will probably witness your computer explode. And then at the end of all this, if iteration is less than light radius, yes, right here, we just have to say world tiles map dot apply. Anyway, that is our light block function done. The next function we need to code is our remove light source function, because if we place a tile, then it's obviously going to remove the light at that tile. So very similar, void remove light source is going to be our function name. It's going to take in a position, obviously, so int x, int y. And this is going to say, first, we have to clear the storage of our dark blocks. So that's all our dim blocks are stored in unlit blocks. We're going to clear it just so we can fill it up again. And then we're going to call a function which we haven't written yet, and that is called unlight block, and it takes in an x, a y, another x, and another y. And we're going to code that next. So that will be underlined for now with an error. Anyway, we're going to create a new list, and this list is going to store a vector2 ints, and it's going to store the blocks that we have to relight. So call it to relight, and basically it's going to relight these blocks which have been updated, essentially. And it's going to equal new list, of course, vector2 ints. Oh. And now we're going to loop through again for each of the blocks inside here and essentially relight its neighbors. So the way we're going to do that is quite an interesting method, and I'm going to code it, and then I'll talk about it a little bit. But we don't have much time in the episode, and there is a lot to do. So let's get started. So for each vector2 int, and we're going to call this block in unlit blocks. So for each block in unlit blocks, we're going to literally loop through its neighbors, same way as we did before. So for int nx equals block minus block.x. Oh, yes, block.x minus 1. Nx less than block.x plus 2, nx plus plus. Nice. And then we have to loop through, obviously, the y-axis as well. So for int ny equals block.y minus 1, ny less than block.y plus 2, ny plus plus. And then very similar to how we did before, we're just going to say, make sure that there is actually a light here. So the way we do that, literally the same. World tile if world tiles map dot get pixel at position nx ny. If it is not equal to null, then we're gonna do stuff. And the stuff we're gonna do first, we have to check to make sure that the light we're currently on is it brighter than the light we essentially want it to be. So world tiles map dot get pixel nx and ny dot r, again r channel. If that is greater than world tiles map dot get pixel at block.x and block.y. And again, open close brackets. That's giving me an error. Why is that? Right, because I didn't write .r. So .r for the R channel, of course. And then before we can add this to our list of blocks to update in our relight method, in our relight sort of list, we have to check one more thing, and that's to make sure that that list doesn't already contain it, so we're not relighting it twice. Otherwise, it's a waste of resources. So if not relight dot contains, and we're just going to check if it doesn't contain a new vector2 int, vector2 int, and the int is of course nx and ny. Typing everything wrong today. Nx, ny. There we go. In which case, if it doesn't contain it, then to relight dot add new vector2 int nx and y. Okay, and again, before we can actually end this function here, we have to relight the blocks in our relight function. So for each vector2 int source in to relight, we're gonna say light block source.x source.y world tiles map dot get pixel. So we're getting the intensity is going to be the intensity at the current block, essentially. So it gets weaker and weaker as it sort of disperses. Of course, is how we want the lights to work. So again, source get pixel is going to say source.x and source.y. So we're getting the amount of light at this position, .r, of course. And then our iteration is going to start at 0 again. And before we can end that, of course, world tiles map dot apply. Just so we can update the texture again. And that is that function done. So now we can call, we can write the unlight block method. And the way that works is like this. So void unlight block. This one is more difficult. Removing light is harder than adding light. So for int y, int x, int y, we need an int initial x and an int initial y. And what this is going to do, it's going to start at the edges of the light and slowly move its way in, basically dampening the brightness, essentially. But before we do that, we have to make sure that the blocks we're modifying are sort of within the range we need to modify it. So we're going to calculate the distance by using a fancy equation. And that equation is mathf.abs. So mathf.abs is mathf.absolute. So we're getting the absolute value of x minus initial x. If that is greater than or equal to the light radius, or we have to do the same for the y-axis, of course. So if the absolute value of y minus initial y is greater than or equal to light radius, and the other condition is or unlit blocks dot contains new vector2 int. Now let me scroll along for you guys. There we go. Vector2 int x and y. Right, just like that. Unlit blocks that contains this. Right, get rid of that space there. Nice. In which case, if that does, if it does contain those, then we're going to return. Okay. And now this is when we start looping through each of its neighbors. Why is this expected? Is it here? There we go. All right, cool. Make sure you write that line correctly, otherwise it won't work. So let me zoom out a bit, pause on the screen for now. Here we go. Pause video here if you need to copy that. And let's get back into it. So to loop, again, very simple how we did every other time. For int nx neighbor x equals -1, nx less than x plus 2, nx plus plus. And then again, for int ny equals -1. This should be x -1 and then y -1. There we go. Ny less than y plus 2 and y plus plus. And again, we have to make sure the tile we're modifying is not the one we're currently on. So if nx is not equal to x or ny is not equal to y, then again, we have to make sure that there actually a pixel there. So if world tiles map dot get pixel at position nx ny is not equal to null, therefore there's a tile there. And then the only thing we have to check is if it is darker. So if the light there is darker than the light we want it to be, essentially from the light source, then we're going to unlight it, if that makes sense. It's a bit confusing, but trust me, it works. So if it's not equal to null, then if world tiles map dot get pixel at nx nx and ny dot the R channel is less than world tiles map dot get pixel at x and y dot R. Oh, this should be if. There we go. Can't spell. There we go. All right, so that should work there. And then we just have to, again, recursive, so call the same function again. So unlight block, and we're going to unlight the block at nx and y with the initial x and the initial y. So the reason we need initial x and initial y is because they store the sort of light's position, the original light's position, and this stores the light we're modifying's position. So I say light we're modifying, it's really just the tile that is bright, but we want to dim it. So this stores tile position, this stores light position, is kind of the way you should think about it. Again, if you're not going to mess around with lighting too much, this is very much a set and forget script. So once we code this, you're never going to have to modify it really. There might be occasion or two you might have to sort of fix things up. There is a couple issues with the code, but there's sort of things I'm not 100% sure how to fix at the moment. But this seems to get the job done 90% of the time. So if you're looking for just some basic light, this should do your work. Should be fine. So again, we just have to make sure that we set the color of that pixel and then apply that to the GPU again. So how we do that? Very simple. World tiles map dot get pixel at x and y, and it's gonna set it to color dot black. This should be set pixel. Yes. And then we're just gonna say unlit blocks dot add new vector to int, and it's going to add x and y. And that's pretty much all our light functions done, but the code won't work yet because we don't have it sort of generating and updating our lights. The way we're going to do that is in our check tile method. So let's scroll up. Is it here? Place tile, no, check tile. So right here, we're going to add 2 lines of code. Right, one's here, and that is remove light source at the position x and y. So check tile is called every time the player places a tile. And then one thing we're going to do is comment this remove tile line out for now, and then write remove light source here as well. Again, x and y. The reason I comment this out is because at the moment when it replaces walls, something kind of seems to go wrong. It doesn't really work very nicely. And I think because we're removing a tile which removes the light source and then we're placing a tile which adds a light source, and it kind of breaks for some odd reason. But you know what, I'll leave it uncommented, and I'll show you guys what it does. So I'll show you guys how it doesn't work. Anyway, with that done, the only thing we have to modify, I believe, is now our place tile function. So here, yes. So if tile dot is in background, sorry, underneath tile dot in background. Here, if tile dot name is if it's a wall, we just have to update its color essentially. You could put this in here, but this gets called either way, so that's why I'm putting it here. It's some Boolean logic. But yeah, so world tiles map dot set pixel x and y to color dot black, and basically that's just saying make sure that it's dark at this spot of the map, because obviously there's a wall there. And then otherwise, else if it's not in the background. So if not tile dot in background, world tiles map, and I'm just going to copy that line there. The reason we have to do that is because otherwise our trees and stuff they get affected by shadows, which doesn't really make sense because they get darkened and whatnot. And like you see the center of leaves being dark, it just doesn't make sense. It's completely wrong. But with that done, I think that should be our code ready to go. So a couple of things we have to set in the inspector, and that's, so you click on terrain, and one of the things we have to do is set the shader and the world tiles map. So world tiles map gets calculated anyway. Light threshold, we hard code the value in, so that's fine. But our material is going to be, where is it? I lost it. Overlay material. Put that in there. Sorry guys, the one thing I did forget to add was world tiles map.apply. And now with that added, it should work. And then as well, this should be equals y minus 1. I'll comment that out for now just to make sure that's not causing any problems. Okay, and we have spawned in. So you can see now that our terrain has some pretty fancy lighting. We did have to fix a couple of bugs just then, but that's fine. If I place a block, you can see that that still works. I can also do this, and you can see that the middle one is darker, as should be. That is perfect. The only thing, like I said, is placing blocks on walls does seem to break a little bit, but that's fine. Breaking blocks here, that updates the terrain. That is all good. Seeing how I can break the back wall, and that sort of like gives me light. That is good. It's meant to do that. So yeah. Apart from that, if I block up light, you can see that it sort of lags for a little bit, which I guess there's not much we can do. If you are lagging too much, the best I can recommend is for you to reduce the light radius. And then that should fix your problem as much as possible. This is another issue we're encountering with if I place a block and then I break another one, it's black because it's updating like that. But then if I place another one next to it, it sort of fixes. So there's a couple bugs like that. They're not terrible. So if you did want to fix them, have a look. I don't know how to personally, to be completely honest with all of you, but this is the first time I've done any sort of lighting like this. So it's new to me as well. Apart from that, that's pretty much today's episode, getting this lighting done. In the next episode, it's going to be entirely bug fixes because there is a lot of them. And there's a lot of people pointing them out to me in the Discord and whatnot. Today was actually meant to be bug fixes originally, but then people wanted to see lighting, so I did lighting. But yeah, apart from that, what I'll do is you'll see a cut here, and I'll just appear straight back to when I've changed that filter mode. If I was to comment that out, that would give me smooth shading. So there we go. I've spawned in the world, and you can see that smooth lighting looks like this. as you can see, there is sort of like a almost like ambient occlusion, which I kind of like. It's all right. It does, you know, it's not perfect. This is a very choppy way of doing it, really. But look, if it works, it works. Doesn't. So again, you can place blocks, and it gives you sort of like nice smooth lighting, which is very handy. You can break blocks, and that's also very handy. Obviously, it is doing that thing again. But yeah, so lighting looks like that. Today, one last thing, and that is to just make sure our overlay is on highest layer possible. So I'm going to set to 10. And what that's going to do is it means now that our player is also going to be affected by light, which is perfect. Break this block and fall down. You can see that my player is also in the dark, which is very nice. And exactly what we want. Because, yeah. Anyway, the reason that works is because our lighting is literally just this overlay, which is quite interesting as well. It also repeats to the sides and whatnot. But yeah, so that's why the big thing you have to do is make sure that when you're setting your world, you also set the world size here. Apart from that, there's one last thing I want to fix because it's been bugging me, and that is, where is it? Here. We're saying if the distance is between this, then you can hit and place, but else if, and I'm just going to copy this, if it's within player range. So else if it's within player range, then if hit dot remove tile, there we go, at X and Y. I am stupid. This should be mouse pos dot X and mouse pos dot Y. There, just get rid of that if statement. That should fix it. Else bit, and that should fix it. I forgot about that. That is it for today. I thank you guys for watching, and thanks for all the support with the series. It's been very fun to do, and I can't wait to make more. All right, I'll catch you guys in the next one.